Hi, this is Rakesh Chaudhary. I am studying in Kara University in BTech in CS department, third year. Now I am explaining about experiment 8, configuration of dynamic routing OSPF in computer networks lab. The aim of this experiment is to design a network topology to perform the initial router configuration required for the connectivity by using the IP address and configure the dynamic routing OSPF version 2 uh, that are, that are needed to allow communication between the hosts. The description of this experiment is OSPF basic configuration is very simple. Just like with routing protocols covered so far, RIP, EHERP, first you need to enable OSPF on a router. This is done by using router OSPF process ID global configuration command. The uh, procedure of this experiment is just simple. Configure IP address and configure IP addressing on the host PCs. Configure the router interfaces. Configure the router to install the dynamic routing in the routing table. Fourth is the test and verify the configuration. Then the result is automatically generated. Command configurations. Use the router OSPF command in global configuration mode to enable OSPF on R1. R1 configure hash router OSPF 10. Configure the network statements for the networks on router. Use an area ID of 0. Similarly, configure for R2 and R1 configure hash router OSPF 10. R1 configure router hash network 172.172.0.0.0.0255 area 0. R1 configure router hash network 172.163.0.0.0.3 area 0. R1 configure router hash network 192.168.10.4.0.0.3 area 0. R1 configure router hash R1 hash. Second thing is verify OSPF neighbors and routing information. Issue the show IP OSPF neighbor command to verify the each router list the other routers in the network as neighbors. R1 show IP OSPF neighbor. B R1 show IP route. Mm. Third is verify the OSPF protocol settings. The show IP protocols command is a quick way to verify vital OSPF configuration information. This information include the OSPF process ID, the router ID, networks. The router is advertising the neighbors. The router is receiving updates from and the default administrative distance, which is 110 for OSPF. This is the topology diagram. Addressing table for R1 FA 0 bar 0 IP address 172.16.1. Subnet mask is as it is for the same default way is 10. Interface is 0 bar 0 bar 0. 172.16.3.1. Subnet mask for SA is 0 bar 0 bar 0. 255.255.255.252. Default gateway is NA. And S0 bar 0 bar 1. IP address 192.168.10.5. Subnet mask is 255.255.252. Default gateway is NA. For R2 device interface R3 S0 bar S0 bar 0 bar 0 S0 bar 0 bar 1 FA0 bar 0. For now IP address for R2 172.16.3.2 192.168.10.9. Another is 192.168.1.1 subnet mask. Uh, 255.255.255.252 is for both 0 bar 0 bar 0 and also 1. For last one, 255.255.255.0. Default gateway is same for all, which is NA. Uh, no R3, router 3. Uh, there will be two interfaces, A0 bar 0 bar 0, A0 bar 0 bar 1. IP address for these two is 192.168.10.1. Another for another is 192.168.10.10.6. Sorry. Subnet mask. Subnet mask. 255.255.255.252. Default gateway is same for N. Same for both R3. PC1 NIC uh, for three PCs interface is same. For PC1 IP address is 172.16.1.2. PC2 172.16.2.2. For PC3 192.168.1.2. Subnet mask 255.255.255.0.2. For both PC1 and PC2. For PC3 is 255.255.255.0. And default gateway for this is PC1 172.16.1.1. For PC2 2.1. For PC3 192.168.1.1. The output will be like this. Uh, for source PC1, PC0, PC0, these are the colors, these are the numbers for the destinations. This is the experiment. Uh, for just result, yeah, hence, hence, we designed a network topology to perform initial router configuration required for connectivity by using the IP address and configure the dynamic routing OSPF V2 is version 2 that are needed to allow communication between the host is